Hi everyone, welcome to the continuation session on trigonometry. In the previous session, we had gone through the 6 trigonometric ratios, namely sine, cos, tan, and their reciprocals cosec, sec, and cot. Today we will see how we apply that in numerical problems, starting with an example. Okay. So this is what we learned last time. Sine theta is opposite by hypotenuse, cos theta is adjacent by hypotenuse, tan theta is opposite by adjacent, and then the reciprocals of those three: cosec theta, hypotenuse by opposite; sec theta, hypotenuse by adjacent; and cot theta, adjacent by opposite. Okay. This was very generic, which means we didn't say whether we are referring to sine A or sine C, angle A or angle C of the triangle ABC. We just said theta, so it could be angle A or it could be angle C, and that's why I just left it at opposite, adjacent, hypotenuse, etc., rather than naming the sides, because the naming of the sides will happen only once we know the angle that we are talking about. However, in the numerical problems, you will be given the angle, either the measure of the angle, or it will say its angle. Find out the ratios for angle A or for angle C. This is the question that you might get, and this is the simplest of the questions in trigonometry, finding out all the T ratios of angle C. So as you see here, now it's not theta. Theta, what they've mentioned what theta is. Theta is angle C. So we are going to talk in reference to angle C. And it also says find all T ratios. Now, all T ratios means the 6 T ratios that we looked at in the previous session. That is sine, cos, tan, cosec, sec, and cot. Okay, so we'll have to find all these 6 for angle C. So this is angle C. This is what we're going to refer to. Now for angle C, now that we know we are going to talk about angle C, we can very clearly mention the sides. This is going to be the opposite side, that is AB. BC is the adjacent side for angle C, and of course hypotenuse will remain the same, AC, whether it's for angle A or for angle C. Okay, so we have this ratio here. Instead of theta, now we can clearly say we are talking about sine C, we're talking about cos C, and we're talking about tan C, right? We know sine C is opposite by hypotenuse, so all you have to now do is to put the side name. So what is opposite? Opposite is AB, right? Opposite is AB. So instead of opposite, I just write AB, and instead of hypotenuse, I write AC. Alright. Same way for cos C, adjacent is BC, and hypotenuse is AC. For tan, opposite by adjacent, that is AB by BC. Now comes the inverse. Cosec is the inverse of sine. So if sine is AB by AC, this should be AC by AB, right? Without looking at the figure. Sec is the reciprocal of cos. Cos is BC by AC, so this will be AC by BC. but I would suggest that you look at the figure and mention this, because if you had gone wrong here, then there is a chance that you will go wrong here as well. But for the, since we already have it there, so cot is inverse of tan. So what is tan? Tan is AB by BC, so this will be BC by AB. So this is the ratio just in terms of sides. Now let's give a number to it. Suppose the hypotenuse is 5 centimeter. This is 4 centimeter adjacent. Opposite is 3 centimeters. Okay. So when they give you this question, they'll give you two things. One is they'll give you the angle. Which angle are you going to find the ratios for? Angle C. And also they'll give you the 3 sides of a triangle. So it could be in units, could be in centimeter or any other scale. So here hypotenuse is 5, adjacent is 4, and the opposite is 3. I can say adjacent and opposite because now I'm talking in reference to angle C. So all you have to do is, instead of AB by AC, instead of AB, what is AB? AB is 3 centimeters, right? So this is 3 divided by hypotenuse is 5, so 3 by 5. What will this be? Cos C. Instead of BC by AC, I can mention as 4 by 5. Adjacent is 4, opposite is hypotenuse is 5. Now this is opposite by adjacent. AB by AC, AB is 3 centimeters and BC is adjacent is 4 centimeter. Same way here, I can either look at the figure and do it. I know this is 5, this is 3, and this is 4. So you can look at the figure and do it, or since you have the sine, cos and tan, you just have to take the inverse. So 3 by 5 is sine, so cosec will be 5 by 3. Cos is 4 by 5, so sec would be 5 by 4. What is cot? The inverse of tan. Tan is 3 by 4, so this would be 4 by 3. So now we have all the 6 T ratios. So this satisfies the question. Find all T ratios of angle C. We know sine C is 3 by 5. Cos C is 4 by 5. Tan C is 3 by 4. Cosec C is 5 by 3. Sec is 5 by 4. And cot is 4 by 3. So these are the 6 T ratios that we derived. Okay, now you could get the same question with just 2 sides given. So here in the example that I gave you all the 3 sides, right? 3, 4 and 5. Suppose you are given only 2 sides. In that case, you will have to find out the third side. And how do you find out the third side? By using Pythagoras theorem. So Pythagoras theorem will help you find the third side. Hypotenuse squared is equal to sum of the squares of the other 2 sides. So one is opposite squared plus adjacent squared. So if you use this formula, you can get to know what the missing side is. Once you have the missing side, then everything remains the same, the same process. So the most simplest one is when you get all the sides given. The next is when they give you just 2 sides and you will have to find out the third side, and then the remaining the portion is the same. There could also be a question which says find all T ratios of angle C and angle A. So you'll have to do all this with respect to angle A the second time. Or instead of all, they might sometimes tell you find sine, cos and tan for angle C and angle A. So it depends on the question. So instead of saying all T ratios, they could specifically ask for only 3, sine, cos and tan, and they'll say either for angle C or for angle A or for both. So depending on that, you will have to figure this out, right? Okay, then thank you for watching, and we will continue with a few more problems related to the same topic in the upcoming sessions. Thank you so much. Bye.